All right. As usual, I like to start these videos with just a quick review of what we've kind of done so far. Um, so we have a card game, new game, and it draws a deck of cards from our lovely deck of cards API. We can draw cards. The number in the middle is showing how many are remaining in this deck, um, and they are being drawn in memory, at least, to the player, myself, the human player. So the next thing we're going to want to do is actually set up, some cards down here of what cards I've drawn, because otherwise this is just this game would be very difficult. You wouldn't be able to do anything. So just to kind of review a bit of the things, in our lib folder, we have a few different components. These are like UI components, widgets, basically. So something that represents the card back that we were just seeing. The deck pile, which is actually just puts the card back on with a child of the number within it. Um, we have the game board. This is where a lot of the magic happens when you're playing a game. And this is where the consumer is of our provider. So essentially, anytime our consumer does this notify listeners, this will rebuild, which will just keep everything in sync, UI and business logic. We also have a component for our playing card, which is just the playing card itself. Okay. What else do we got? We have some models. We have a model that represents the card itself, which is something we're using a lot. This comes from API, so we have a factory that converts the JSON to a card model, which just has a couple strings to represent the image and the value, as well as a suit, which is an enum we made representing the suit. We have some helpers to convert a string to a suit and also a suit back to a string. We have some helpers also for color and kind of getting the emoji symbol of these things. Okay, so yeah, there's models. We have our game provider. This is, probably where the most code will be written once we kind of get everything in place. This essentially just manages the state of the game, has functions for creating a new game, setting up the board, drawing the cards. What's cool is eventually we're going to be converting this to an abstract class, and we're actually going to build a specific game, Crazy Eights, for today. Um, in that inherits this. So ultimately, game provider will kind of be like a convention that is made that has a lot of the helpers and stuff, but will override certain things. Like for instance, setup board right now just doesn't do anything. It still gets called, but doesn't do anything. But once we have an abstract class, once we're able to inherit this abstract class, we can create, in Crazy Eights, everyone gets dealt 8 cards, and the first card gets flipped into the discard pile. That's the kind of stuff you can do that will be different between, say, Go Fish. Aside from that, we have some screens, really just one screen. This is really just the scaffold of the entire game and has the button to create a new game. We have a service as well. We have our deck service, which talks with our awesome deck API. And that inherits something that we may call API service, which is just a really basic thing that interfaces with HTTP library, the official package HTTP. That way we can just work with it in a nicer way and not have to, hard code in, for instance, deck of cards API. So that's kind of it. There's a few constants, just representing our card width and card height. We obviously have our main.dart, which all it's really doing is invoking the game screen, and it's also registering the provider. So that's kind of where we're at. And let's get to it. So the next thing we want to do is actually kind of create, something that's going to show the player's cards here. So I do want to make a new component for this, and I think we'll call it a um, not no, it's not the discard pile. This should be you could call it like a card hand or something. Um, Naming stuff is hard. I'm just gonna call it player hand dot dart. Okay. So what we can do, uh, let's actually call it a card list, I think. It's a little more descriptive. And we will make that a stateless widget to start. It may get upgraded at some point, but card list is cool. We'll import in material. And we need some things when you sort of create this. So first of all, let's just so we can kind of keep that idea of size, just so we can make this more scalable in the future, we will allow passing a size in. We will also, a card list should be owned by a certain player, so we'll use our player model and we'll call it player. Let's also have a function that we can pass through. And it will be optional, so we can do this. And on play card, and this will make a little more sense after, I'm sure. And when we do a play card, we want to pass back a card model so that whatever is in, making use of this knows what card it is when the on play card is hit. That's essentially going to be, on pressing a card. We need to, in our constructor, have some things. We definitely need, we're going to require this dot player. We need that. This dot size is going to be 1 by default. It's kind of just a ratio of the card size. And we won't make this required because it is optional due to this question mark here. All right, now into the UI sorts of things. First of all, we want to make sure that this list kind of has a a height. Now this is going to be a horizontal scrolling list, so it's going to kind of go across the bottom here. So we do want to give it a height so that it doesn't get confused. So I'm actually going to replace this container with a sized box because we don't need to style it necessarily. And we're going to give it a height of whatever the card size is, which is that the card height, which is that constant we have, multiplied by whatever our size is. That'll just keep things nice. And its width is going to be double dot infinity, which is just basically a fancy way of writing 100%. And it's going to have a child. And this we're going to have a list view builder. List view dot builder. I will erase these so we can do it one. First of all, as I mentioned, we want a scroll direction of axes dot horizontal instead of the default vertical. Item count. So we have the player being passed down. And if you remember the player model, one of its attributes is a list of cards, which by default is just an empty array, an empty list, but could have many cards in it. So that's what we're going to kind of use. So we can do player.cards.length. That's how many items there are. And then in our builder, we also need in our list view, we need an item builder, which takes context and also takes, very importantly, an index. And in here, we will make a function, and it's going to return something. Now, what I like to do is, rather than every time having to access it this way, it's nice to just make a variable called card, and it's going to be equal to player.cards index. So if you're not familiar with list builders, let me just, I'm just going to return a container so this can look nice. There we go. They are really efficient because they kind of like figure out all the math and heights of everything and all that kind of stuff. But it keeps a lot of the, if your list is really long and isn't going to be visible on the screen, it's efficient and keeps those things kind of like low memory footprint as possible. So basically what happens is this function will be called for however long your item count is. So if we have 10 cards, it's going to be called 10 times. An index obviously starts at 0 and would go up to 9 in that case, meaning we would be, in this case, returning a 9. If there was 10 cards, we'd be returning 10, 10 containers all in a list. But we obviously don't want to return a container. We're going to return a playing card, which is we've already made this. This is essentially where you pass in the card model that represents it, and it gets uses the network cache network image, which uses whatever card's image it is to display it, et cetera, et cetera. So we have a playing card. Now we need some things in here. We obviously need to pass the card, and we already have this here. Size, let's pass size just straight through. Visible, let's just do true for now. We can make that dynamic after. And on play is something that we will eventually want to do, but we don't have that set up yet. So let's just see if this even, works. So we have, I'm just going to just restart. Oh, we also need to, so we've built this, we've built this, yay. It's not going to show up though, because we have to put it somewhere. So let's go to our game board. And essentially, just to remember what's happening, we kind of have this, this stack, right? And we put So far, it's kind of useless to even have a stack because we only have one thing, but we were planning on having other ones. So we're going to put another thing in this. Now, with a stack, you can wrap any of your things in a line to say where in the stack it lives in like X and Y space. So in this case, let's do align, alignment dot bottom center, sure. And we'll give it a child, and its child is actually going to be the card list we just made. And we can pass in a player here, right? So player, and in this case, let's just do model.players one. Or would it be 0? Let's use 0. 0 would be us. We're the first player if we go back and look at our game. So let's do that there. And new game. And if we draw, nothing's happening. I wonder why. All right, I realize we did miss a pretty important thing. So we are, in our game provider, we are drawing cards, but they're essentially just kind of going to the abyss. We're not doing anything with the draw. So what we need to do is actually when a draw happens, we know what the player is, and we need to add these, add whatever cards get drawn to that player. So what I'm going to do is in our player model, we're going to essentially add a function. And to allow us to sort of add cards easily. So I'm going to just call it add cards, and it's going to take a list of card models, and we'll call it new cards. And all we really need to do here is go cards equal whatever our current cards is, and then spread to add in our new cards. This is just a fancy way of combining two arrays, essentially, two lists, rather than kind of like doing, you could also kind of do cards dot, I think, add all and pass it in, but this is good. Cards equals whatever our cards are right now, and new cards. While we're at it, let's also make a remove card function where we can pass in a card. And what we can do is we can take our cards and remove where. And this is kind of like the case that we want to check to whenever we move it. So this is going to loop through all the cards, and we'll represent each in the loop as C. And we want to just check if C dot value is equal to card dot value. So if the C in the list value is equal to this card's value, and we also want to make sure C dot suit is equal to card dot suit. So it'll remove any time, like it could, in theory, if you were playing multiple decks, it could return, this could actually remove multiple. We could just do remove first where, or remove, there's something similar. But anyways, this will work for our needs. And while we're at it, while we're in this thing, let's just make we have sort of like something representing is human. But it might be nice to have a getter just called is bot. We don't have to store it or anything. It's just a function that will return the opposite of is human. That way, if our logic is like we want to know if it's a bot, we can just ask without having to, go if not is human. Just fancy stuff. Okay, awesome. So we have our drawing of cards, the draw happens. We want to make sure right when the draw happens, we then take whatever player is passed into the draw card function and add those cards. So we can go draw.cards. Sometimes it might just be one card, but it will work as long as it's a list. And as we know in the draw model, this is a list that comes back, even if it's just one. So we have that, and we should be good. Okay. There we go. Okay, so I'm just going to refresh so it's kind of a clean game. But 52 cards in the deck, and I start to draw one. And you'll see that I can, continue to draw these. So this is pretty sweet. This is coming for API. Now, because this is a horizontal list, you can scroll it. If you're on Mac, unless you get a plugin or something, you have to kind of use your, because it's horizontal, hold Shift and mouse scroll wheel. Obviously, if we deployed this to iOS, it would just be, or iPad or something, or Android, it would be, a touch sensitive thing. But this is good. So we're getting cards. Yay. Okay, so in our very, very basic preliminary game, the way it's going to work is at first, you're allowed to draw one card and only one card, and then you have to end your turn. So we need some functionality to allow ending of a turn. In order to do that, let's go back to our game board. And what we can do is, where we did this card list, which is right here, let's actually put this into a column. Now I'm going to make the columns height, main axis size dot min, just so it doesn't try and take up all the space it can, as columns like to do. So everything should still be the same. But within here, we're going to want to put a button. So what I'm going to do, just because we might eventually have multiple buttons, is we'll actually make a row here and give it some children. Cool. And let's just make the main axis alignment dot end, so that they kind of go to the end. And in here, we're going to put a button. We'll use an elevated button. And on press, we'll keep empty for now. And child will just be text of end turn. And this can be a constant. So now if we go here, we'll see the end turn. Might be nice to either put padding, or you could simply just have a size box height of like 8 or something. And this can be a constant too. This will just add a bit of padding between there. And in fact, now that I'm seeing this, let's actually put padding around the entire row. We'll wrap with padding, and then it kind of has it on both sides. So we have a lovely end turn button, which doesn't do anything yet. So first of all, in our game provider, I want to make some other helper functions. One of them is going to be it's going to return a Boolean, and it's going to be can end turn. And for now, and this is actually going to be a getter. So bool get end turn, and let's just return true for now. We'll just be like, yeah, you can always end your turn, and we'll update that logic later. Meaning, what we can do here is we could decide, we can use model.can end turn and have a function, and then otherwise do null. And I didn't save this file, so we got this error. And if we actually made this to return false, you'll see that this button's going to be disabled. So that's pretty cool. So we have that now. Then how do we actually end the turn? So we're going to make a function, and it makes sense to be kind of in the same spot as can end turn. So we're going to make a function. It's void, returns void rather, and we'll call it end turn. And remember, we have this turn object that we can do things, and it actually has, I think, something called next turn. So let's just look at what that looks like. So next turn increments the index of what turn we're on. It figures out who the current player is, and just this simple sort of function to find out if it's even or odd. And it resets the draw count and action count to 0. So we can do turn, next turn. And then because we're going to be, working with a bot, after we change the turn, we can actually in this point check if turn.currentPlayer.isBot. Remember, we made that function very recently, or that get. We can call a function, and we'll call it bot turn, which we haven't made yet. We also want to make sure at the end of this we notify our listeners, so that state updates. So let's make another function called bot turn, and I'll just keep it empty for now. Sweet. Okay, so now if we were to end turn, what's actually happening, if I'm clicking this, let me make sure I'm right. So, it's still giving it to me, right? Okay. So what happens here? Oh, right. Our card, okay, deck pile. Right, we're just drawing cards to the first player all the time here. Really what we want to do is, I think we have something called current player, or dot turn, or model dot turn dot current player. We really want to be drawing to, whenever that's clicked, to whoever the current player is. So let's just see if this even works. So I get my one card. If I was to end my turn and click here, it's still coming to me. I wonder why. Current player. Our logic might be wrong on the turn. Let's see. Current player. So we're doing end turn. We do the bot turn. Notify listeners. Let's just, after we end turn, let's just print turn.currentPlayer.